Okay, in the next assignment, you have to implement this process to solve a system which is composed by bar beams in the plane. And that's what we call a frame, okay? A frame in a ship, okay? Maybe you remember in the last part of the previous semester that we have, for example, deck beams, side beams, bottom floors, and things like that. And we said that we could analyze that as a combination of bars and beams. And that's what we're going to do in this exercise, okay? So let's review the process to implement this. That's this part of the class. Let's see if we can do this. Okay, so let's talk about implementing the finite element method. In this case, of course, we're working with bars and beams.
Doctor.
Yeah. Oh, and I'm not sharing. Yeah, I'm not sharing the screen. Yes, I'm sorry. Thank you. Thank you. I'm sorry. Okay. Can you see it now?
Yes, sir.
Okay. So I'm talking about implementing finite element method, bars and beams in the plane. That's what we're doing right now. Okay. Now, when we started this semester, we said that there are certain standard steps in the finite element method. Okay. Of course, in this case, since we are specifically using these two elements, the discretization is already being started. So we skipped the first step, okay, since specifically we are going to use line elements for our discretization. Okay. So in the general process, we have to start by discretizing, right? Or selecting the elements. Okay. In this case, since we are specifically using line elements, we don't need to do that. We're assuming that that's the type of elements that we're going to use. Okay. Now, after that, we have to select the interpolation process. For the bars is linear, for the beams is cubic. Then we have to proceed to calculate or to accept or to take relations between displacement at the joints and external forces. And we do that using the direct method, okay, which assumes that we're working below the elastic limit. So Hooke's law works fine with us and things like that. And we reach then we already took interpolation, polynomials, and deduce stiffness matrix. This is little k, people, for the elements. And we know this completely. Okay? Let's proceed. Well, with this, I mean, let's calculate the rest. Okay, so we have to go on. We have already discretized. We have already selected the elements, line elements. That's all what we have available so far. And we have to go on. So remember, now we have to form the global matrix. Then we have to calculate and implement external forces concentrated, because this is discretization. And also, there are certain geometric boundary conditions that we need to implement in order to take the singularity of the problem out. And then we have to proceed to solve for the displacement first, for the reactions as a second step. And then we have to go back to each element, okay, to calculate the internal forces. Okay, so let's go step by step. Okay, so in your implementation, what you need to do is to read the information from an external file. Okay, so the thing is this: what information in this case do we need to include in our program? What information do we need to read from this external file? Okay, so let's go on. So to complete this task, we need, I need some space here, the following. Data. Okay, for example, let's suppose that I'm going to analyze this simple transverse frame. Something like this. This is the frame that I'm going to need. So what information do you need for this? Okay, so let's suppose that we have discretized. So each one of these is a joint. There. Let's suppose that we have up to here. And let's suppose that up here, we have distributed load. There. Okay, that's the problem that we want to analyze with bars and beams. Okay, so what information here do we need to solve this problem? Mr. Carrion, tell me something. What's the first thing that we need to do to specify?
If I will apply the finite element method, we need first
finite element method.
Sorry, finite element method.
You don't need to say sorry. You don't need to say sorry. We're just trying to improve. Go on. What's the first thing that we need to include?
We need firstly organize the scheme by elements and joints.
Exactly. So for that, we need joints and we need elements. Okay, so for joints, I guess we need the number. And also, since we're working, remember, this is a plane. Let's suppose I include a reference system like this. So this is the global reference system. So in here, I'm guessing that when you said information about the joints, you need a number and also positions. So for each one of them, I need XY position in the global reference system. Okay, with these positions, you can calculate the length of each element and you can calculate the angle of the local reference system with respect to the global reference system. That's it. Okay, elements.